Okay, so we're in Chapter 7 and we're going to be in 7.6, which is translate English phrases and sentences into algebraic expressions and equations. And we're going to use that to solve word problems. So algebra is a very useful tool for solving real-world problems, but in order to use it, you must find it necessary to translate simple English sentences and phrases into mathematical expressions or equations. In technical work, especially, the formulas to be used are often given in the form of English sentences, and then you must rewrite them in algebra formulas before they can be used. So here's an example of that. We've got a problem that says the horsepower required to overcome vehicle resistance is equal to the cube of the vehicle speed in miles per hour multiplied by the frontal area in square feet divided by 150,000. Okay, so we've got two different statements, the horsepower, or they've used P for power right here. And if we look at the statement up here, if we kind of analyze this, it says the horsepower required to overcome vehicle air resistance. And this is very important. This is right here, because is just a fancy way for saying equals. So the horsepower required to overcome vehicle air resistance, so we're talking about the horsepower, and in this one they've called it P for horsepower, is, well, that's going to get me my equals, okay, is equal to the cube of the vehicle speed in miles per hour. So we've got this cube of vehicle speed in miles per hour. They wrote that two different ways. So they said either miles per hour cubed, which is raised to the third power, or this one they've used the letter V to represent vehicle speed cubed. And then we're going to multiply that. So that's also an important word. So we're multiplying something by the frontal area in square feet. So they've got our area right here. And this formula they've called area A, all divided by 150,000. So they've got these formulas that they basically got from our words, and it's going to be important that you're able to kind of interpret those things. So we have certain words and phrases that appear again and again in statements to be translated. They are signals alerting you to the mathematical operations to be used. Here's a handy list of the signal words and their mathematical translation. So equals is supposed to be the word equal. Is equal to, was, are, were, the same as, what is left is, the result is, gives, makes, leaves, having. All of those are like saying equals. Okay. So we have some other words that we can talk about. When we talk about a plus sign, we talk about plus, sum of, increase by, more than, A and B, minus, subtract, less B, decrease by B, take away B, reduce by B, diminish by B, B less than A, B subtracted from A, the difference between A and B. So all these kind of things are talking about subtraction. Times, multiply, multiplied, product of, divide, divided by, quotient of. Twice as much would be times 2. Double also means times 2. Squared, you're raising something to the second power. Cubed, you're raising something to the third power. It's kind of hard to see that. So the cubed is saying a to the third. Okay, so there's some key words there that you can look back on to see that part. So it says the phrase less than has a meaning very different than the word less. So 8 less 5 means 8 minus 5, but if we say 8 less than 5, look how these are backwards. This is one that you really want to be careful with. You're going to say 5, see how they've switched? So when it says this, you want to do 5 minus 8. Okay, if it's 8 less than 5. So far, we have translated only phrases, pieces of sentences, but complete sentences can also be translated. An English phrase translates into an algebraic expression, and an English sentence translates into an algebraic formula or equation. So the height of the duct is equal to its width. So we've got height is equal to its width, or H is equal to W. Each word or phrase in the sentence becomes a mathematical term, letter, number, expression, or symbol. Translating English sentences or verbal rules into algebraic formulas requires that you read the sentence very differently from the way you read stories or newspaper articles. Very few people are able to write out the math formula after reading the problem only once. You should expect to read it several times, and you want to read it slowly, no speed reading. The ideas in technical work and formulas are usually concentrated into a few key words, and you must find them. If you find a word you do not recognize, stop reading and look it up in a dictionary, textbook, or a manual. It may be important. Translating and working with formulas is one of the skills you must have if you are to succeed at any technical occupation. So here we have the electrical resistance of a length of wire. So we're talking about the electrical resistance of the length of wire. Okay, this is important, is equal to, we know that represents the equal sign, the resistivity of the metal, okay, here's another keyword, times, which we know that that's times the length of the wire divided by another key word, which is this is our division, the square, so that's important, the square, which is raising something to the second power of the wire diameter. Okay, so it says to eliminate all words but the key word. So resistance equal to resistivity times the length divided by the square of the diameter. So basically it's kind of eliminated all of these ofs and these, and we're just going to talk about what we're calling this. So in their formula, they've got, this was their words that we highlighted that we talked about. Okay, they've used R for resistance is equal to the resistivity. Now they used a little r to represent resistivity because they used a big R for resistance. Times would be multiplied by L. Some of you may still want to write that with the little times sign in between it, but you need to know that those two things mean the same thing. And remember, we took the times out because we didn't want it to look like an X, so that's why they've got them written R times L right beside each other. And it's divided by, so that's why we have the division sign, the square of the diameter, which they're letting D equal diameter, so diameter squared. Okay, if the resistivity, R, has units of ohms times inches, L and D will be the inches. The resistance, R, will be the ohms. Now that you can translate English phrases and sentences into algebraic expressions and equations, you should be able to solve many practical word problems. Okay, so here's some steps. The following 6-step method will help you to solve any word problem. You want to read the word problem carefully, noting that information is given and what is unknown. Assign a variable to represent the things that are unknown. If there are additional unknowns, try to represent these with an expression involving the same variable. You want to write an equation using the unknown and some given fact about the unknowns in the problem statement. Solve the equation. Answer the original question. Be careful to state the value of all the unknown quantities it asks for in the problem, and then check your solution. So we have a total of 66 cubic yards of concentrate. So this is something, we have a total of 66 cubic yards of concentrate. So we've got concentrate, right, is, which is our equal sign, required for a pour. So we've got 66 cubic yards of concentrate is required for a pour. The combined amounts of cement, sand, and gravel should be 1.5 times the amount of concrete needed. For this particular job, cement, sand, and gravel must be combined in the ratio of 1 to 2 to 3. What volume of each component will be necessary? Okay, so remember that we said the first thing is that we need to we might have to read the problem multiple times. So a total of 66 cubic yards of concrete is required for a pour. So in this context, we're not really needing to make this an equation. It's just saying that this 66 cubic yards is required to make for a pour. The combined amount, so we're saying the cement and the sand and the gravel should be 1.5 times the amount of concrete needed. Okay, so the cement, the sand, and the gravel are supposed to be 1.5, now this is important, times the amount of concrete needed. Okay, so I already have something right there. I know how much concrete I need. I need 66 cubic yards. So I need to do 66 times 1.5 because it says that there's 1.5 times the amount of concrete needed with all three of these combined. And 66 times 1.5 gives me 99. And that's going to be in cubic yards, which was my original. So I actually need this much of the 99 cubic yards of cement and sand and gravel. Okay, so that's what I know so far. I need 99 cubic yards in order to make this 66 cubic yards of concrete. I need 99 cubic yards of cement, sand, and gravel all together. But this is also important. It says that these are in the ratio of 1 to 2 to 3. Okay, so it says what volume of each component would be necessary. So what I'm looking for is how much cement do I need? How much sand do I need? How much gravel do I need? And I can't just divide that 99 by 3 and go, well, 33, 33, 33, because it says that it's got to be in this ratio, 1 to 2 to 3. Okay, so when you look at that, I would add, so 1 to 2 to 3. I could say, well, how many what total is that? 1 plus 2 plus 3 gives me 6. And so when I look at these things, if I have something that says 1 to 2 to 3, okay, then that means that 1/6 of it is going to have to be cement. 2/6 of it is going to have to be sand. 3/6 of it is going to have to be my gravel. Okay, well, I should be able to figure that out. Okay, by doing, and they've got it worked a little bit different, but it's the same thing. They said cement would be 1x, gravel would be 2x, and sand would be 2x, and gravel would be 3x, but it's the same difference as what I'm doing. So if I take 1/6 times 99, okay, pardon me, 1/6 times 99, that's going to get me 16.5 cubic yards, and that is going to be my cement that I need. If I do 2/6 times 99, I'm going to get 33 cubic yards, and that's how much sand I need. And then to figure out the gravel, I would do 3/6 times 99, and that's going to get me 49.5 cubic yards of gravel. And those would be my answers of what I would need for each one of those. Now they've got a different way that's very similar, but a different way than how they work that problem out, and it's fine to do it that way too, okay? So this says that the ZG&E utility charges customers who generate solar energy a monthly fee of $15. Because they often net energy metering, they compensate the customers 4 cents per kilowatt hour of net electricity returned to the grid. The Ready Edison utility charges solar customers a maintenance fee of $20 per month, and they compensate the customers 6 cents per kilowatt hour of net electricity returned to the grid. Suppose we wish to determine the amount of net return for which the two plans would result in the same monthly bill. Okay, so we've got two equations here they've set up. 15 minus 4 cents times x. Okay, so when we look up here, we can see that the customers are going to be charged a monthly fee of $15 if they generate energy. Because they offer net energy metering, they compensate the customers for 4 cents per kilowatt hour. So they get charged $15 up front, but then they're going to end up getting to make some money, so they're subtracting off this 4 cents per kilowatt hour. And then it says that the customers, that Ready Edison utility charges a maintenance fee of $20 per month, and they compensate their customers with 0.06 kilowatt hours. So that's where we're coming up with the 20 minus 0.06 per kilowatt hours. Now, in this problem, it says we want to determine the amount of net return for which the two plans would result in the same monthly bill. So they're saying that they want to know what X would be that would make these two statements be the same. So what you would do is you would just set them equal to each other. So 0.06x. Now, we've talked about how to solve equations. One thing we want to do is get our x's on the same side. So we could add 0.06x to both sides of our equal sign. Okay, that would get me 15. Negative 0.04 plus 0.06 would get me plus 0.02 times x is equal to 20. Okay, then remember that we're going to go to the side with the x on it. We're going to get rid of the thing that's not connected to the x, so we would subtract 15. Okay, and then that would bring down my arrow. 20 take away 15 would be 5. 15 minus 15 is 0, so 0.02x would be on this side. We need to divide both sides by 0.02. These would cancel out, and we'd get x is equal to 5 divided by 0.02. Okay, and 5 divided by 0.02 is 250. Okay, now 250 what? So remember that we were talking about kilowatt hours on the grid. So this is at 250 kilowatt hours. That's whenever both companies would end up paying the same thing to their customer. So it wouldn't matter which electric company you went with. At 250 kilowatt hours, you would get the same for both companies. Okay. Example 6, suppose that an auto mechanic has collected $1,468.63 for parts, including 6% for tax. For accounting purposes, he must determine exactly how much of the total is sales tax. If we let X stand for the dollar amount of the parts before the tax was added, then the tax is 6% of that, or 0.06x, we have the following. So they've written out our equation here. X is the cost before the parts, or X is the cost of the parts, but we know we're charging 6% sales tax, so we would say 0.06 times the cost of the parts is equal to $1,468.63. Well, these are like terms. We could put this together. Remember, this x is really 1x, so 1 plus 0.06 times x is equal to, okay, now remember that we want to divide by whatever is in front of the x. And so this should give us the cost of the parts, because x stands for the cost of the parts, so we would do 1468.63 divided by 1.06. Okay, and we're going to get $1,385.50. So before the 6% sales tax, that's what the cost of the parts were. When fuel costs increase, more people consider the purchase of a hybrid car, and they need to make informed decisions about whether such a purchase will save them money in the long run. Consider a vehicle that is available in a hybrid and non-hybrid model. The following table shows us several pertinent facts about the two models. So we've got the purchase price here of the hybrid, the miles per gallon, and the tax credit, and the same information about the non-hybrid. Now let's assume that the average price of the gas is $2.50 per gallon. We wish to determine how many miles of driving it will take before the fuel savings of the hybrid will make up for its greater initial cost. Okay, so determine the difference in their initial costs. The tax credit on the hybrid reduces its initial cost to $29,500 minus $2,200. So we ended up getting a rebate for this. So we ended up, for the hybrid, we ended up paying $27,300. So for the vehicle that was non-hybrid was $25,000. So they actually had a difference of cost of $2,300. Now, to determine the cost per mile for each of the two vehicles, we would want to do the dollars divided by the gallons divided by the miles per gallon, so that we would get our gallons to cancel out, and in the end we get dollars divided by miles. So we've got $2.50 per gallon divided by 28 miles per gallon, which is 89 cents per mile. And then for the non-hybrid, we've got $2.50 per gallon divided by 20 miles per gallon, which is 0.125 cents per mile. Okay, and then finally, we can kind of compare these. So next, you're going to set up the equation. Let x be the number of miles one must drive to make up the difference in the initial cost. At what value of x will the difference between the cost of driving the non-hybrid, which was 0.125 times x, and the cost of driving the hybrid, which is 0.089 times x, be equal to the difference in the initial cost, which the initial cost of the vehicles were $2,300 apart. So we're going to subtract these two things. 0.125 minus 0.89 gets us the 0.036 equal x times x equals 2,300. And then to get this next thing, we're going to need to divide both sides by 0.036. And that's how they're coming up with this 63,888.88. Therefore, it will take approximately 64,000, when we round, 64,000 miles of driving before the fuel cost of the hybrid will make up for its greater initial cost.